there and welcome. My name is Michael Fudge. I'd like to welcome you to IST256, Applications Programming for Information Systems. This survival guide is really just a basic rundown of the course and the tools that we will use. Let's begin with a course overview. In this course, you're going to learn how to code. We will use Python as our programming language. It's definitely one of the most popular languages of today. Very versatile language. You can do a lot of different things with Python, as you'll see in this course. We take the perspective of information science, data science when we learn to code. So we won't be building end-to-end applications. We'll be using computational notebooks and writing code that's more linear in fashion, that's used to solve data-oriented problems. So most of our problems that we solve in this class consist of data that we collect or gather from somewhere and then manipulate to create a solution around the problem with the data. This is a very common thing in business-oriented and research-oriented programming. So it's very useful not only for people in the information science fields, but also people in the humanities fields and the natural sciences as well. And I believe that learning to code is a 21st century skill. Programming is how we talk to computers, and learning how to talk to a computer can only make you better at understanding computing in general. The philosophy behind how I teach this course is based on a lot of science, the science of learning. This is a very difficult subject for some students to grasp, so it's important that I build foundations that are there to help you be successful. And one of the ways I do that is by basing the structure of the course on some best practices. So we learn best through experimentation and failure. So you'll be doing a lot of that in this class. You'll be trying things out and they work or they don't work, and that's okay. But the important thing to do is to learn from what you're doing. So practicing is important, and learning from that practice is how we grow as a learner. We will experience some spaced and repetitive practice in this class. Basically what that means is your practice will occur throughout the week, and you'll do a little bit each day of the week rather than do it all in one large chunk. So I don't want you to binge this class and work on it like just on a Monday for 6 hours. That's actually not a good way to do it. The course is designed so that you do it a little bit, a couple minutes here, a couple minutes there, several times a week. You'll also notice that things are due at the same time each week, and that's because you build good habits through routine. So when you first start out, first couple weeks might seem rather kind of obnoxious that all these things are due, but eventually by the third or fourth week, you will get into a rhythm, and you will find that you become very efficient with your time. So I encourage you to just embrace it and just let it, like I say, just kind of let the course flow over you, and you'll get better, and you'll also get a very good sense of time management in the class if you just sort of let the due dates come and do the work as it's assigned throughout the week. And the most important thing here, I would say, is reflecting on our learning. So it's important that as you do the work, whether it's a lab or a homework, that you write up in your own words what the experience was like. What was the troubles you had? What are you proud of? What do you feel like if you did an assessment of yourself? What do you feel like you would need to work on more to become better? And this is one thing that I do often as someone who now is in a phase of their lives where they teach themselves many things. No one taught me Python. I learned Python on my own. And one of the key elements of getting a bachelor's degree is understanding how to teach yourself. And with that comes assessing yourself, right? And being able to measure your own learning. And that's an important part of this course. And I'm hoping that you grow with me here and you embrace it and leverage that and learn and use it in other classes that you take throughout your career here at Syracuse University. Learn to learn, and that's going to make you the best student you can be. So reflecting is a key important part of that. It seems weird at first, like, I'm talking about my learning experience and it becomes a little awkward, but after time, you get a lot better at doing the reflections. So the course is made up of what are called formative and summative assessments. The best way to explain a formative assessment is it's participation / effort graded. So we're not really focusing on correctness of the work that you're doing in the lab or the recitation or the homework. That's not the point of a formative assessment. The formative assessment is to practice and to learn as you go about doing what you're doing. As you complete the lab or complete the homework, you should learn a lot. You should come out of the homework or lab smarter than when you went into it. 35% of your grade is based on the formative assessment. So I would classify these as the easy grades in the class. Everyone should do well here. It's about showing up and doing what's expected of you when it's expected. Summative assessments are the traditional assessments that you probably associate with a course, an exam or a project. The part of learning is over at this point. When you take an exam, it's a measuring stick. It's what do you know? Show me what you've learned. Okay, at that point, the learning has been practiced theoretically, and now it's time to assess or measure what it is you've learned. 55% of the class is made up of summative assessments, or I call them high stakes assessments. So you have your formative assessments, practice, and then you have your summative assessments, the measuring sticks showing us what you've learned. So each week is the same, but only the topic change. So before Monday's section, there's some readings and some videos that you can watch. This is kind of like a passive learning experience. You'll go through, you maybe do some reading, maybe do some light interactions. It might get your head thinking about questions that you might want to ask about the topic or how the topic works. And that's what main section or the large group section, the lecture on Monday, is all about. It's Q&A and demo. It's reinforcement of the concepts that you saw and witnessed in the readings that you did before Monday. So you might do those readings, an hour before class or maybe on Sunday night. Doesn't matter. It's just important to come into Monday's class with a clue, as I like to say, an understanding of what it is we're about to talk about. After Monday's section is over, there's a lab that you can complete. It's self-paced. You do it out of class. It's a formative assessment. Should be easy to complete. If you have some struggles with the lab, there's actually a video that you can watch that walks you through how the code is written within the lab. In your Wednesday recitation, you will usually start out with some Q&A. Mainly, your instructor will formulate some questions or activities around what you did in the lab. So it's sort of like a feedback loop. You complete the lab, we review the lab. Your recitation instructor might create a set of exercises or a set of questions or maybe some quiz questions that don't count for anything associated with what came out of the lab. So just to help reinforce that learning. And then you'll do a coding assignment as a group. The entire class together will work on the same assignment. When you're done with your recitation, at the end of the recitation, you will turn in that coding assignment. Sometimes you might not get through the whole assignment. That's okay. That just happens to be the way it is. Sometimes it's a little longer than we have class for, and that's no big deal. It's important to participate in your recitation, and that means when we ask for code, giving code, whether your code is right or wrong is irrelevant, honestly. We actually learn better from code that doesn't work than code that just works perfectly, right? We can all try to understand how to fix it. After your recitation, you have 2 days, 2.5 days to work on a homework assignment. This is an independent coding assignment that you must complete, usually by Friday. Depends on your recitation instructor. Some of them may let you hand it in over the weekend. It really is something that you have to talk with your recitation instructor, but technically it's due on Friday. That assignment is still a formative assessment, but we do ask that you work alone. So we don't want you kind of like teaming up, pairing up, sharing code. That is not what this is about. This is a way to measure yourself effectively and try your hardest to complete something and then reflect upon it so that you have a keen assessment of where you are in the course. All right, in this next section, we're going to run down the various course tools that we use in IST256. Let's start out by looking at the course content. So there are 3 key parts to this course from a content standpoint. First, there's Blackboard. Blackboard's sort of like your hub, keeps everything together, but actually none of the content lives in Blackboard itself. There's just links to where things are in Blackboard. And I'll show you that now. So I'm in Blackboard as a student, and you'll see that when you click on Syllabus here, you go out to a website, IST256 IST256.com. And this is where all of our content lives. It lives out here in IST256.com. If you're looking for like the readings, for example, for any given week, on the main page of the website, or if you go back in Blackboard and you go to course content, same idea, you will be taken to this list, and it has all of the different topics. You select any given topic and you see the content. The reason I like doing it here rather than doing it in Blackboard is it's searchable. So I can go up here and search for loop, and it will find the content where we talk about loops in here. And you can click on the search in here and see now I'm in chapter 4 on iterations. That's where we do looping. So it's really kind of nice if you're looking for a tutor. You can type in tutor up here in the search, and it comes up with a section out of the syllabus on tutoring. If you go to the course content again, and let's just pick out the first unit, you will always see first the reading. And there's usually a video, and the videos are marked with a little video icon here. So I'll go down to lesson, 7, and we'll go to required reading. And you'll see that there is some videos here. There's an end-to-end example that was done by me. And then there's some chapters out of Python for Everybody. So our main text in the course is Python for Everybody from Charles Severance. There's 2 parts to that. There's the actual text from the chapter, and then there's videos where he discusses what's happening. So these are excellent supplemental content for the course. If you're looking for like another way to consume the course materials from someone else other than me, this is great. These end-to-end examples are really great as well. They walk you through writing a Python program from scratch. This is the web version of the book. And, you can see that there's some text to read and things like that. And eventually what you'll notice if you get down into the right chapter here, I think this one might not be it, is some of these chapters, let me find one here. Some of these chapters, I'll go to like go to the iterations chapter. They have some little code snippets that you can run. And I'll show you an example of this. Right here, this is called a trinket. So this is this code in the browser. It's Python that you can run. You can also copy this code and paste it into the Jupyter Notebook tool if you want to save it. But this is a great way to sort of learn. Severance is talking about some stuff up here, but now you want to see it in action. You can come down here and just click this play button and run the code. And see, now it's saying enter something. So I'm going to type in Mike, and then maybe Fudge, and then it won't stop until I type in done. See that done? So I'm going to type in done, and now it's done. Okay, so it gives you a chance to run the code that was written. You can also mess around with the code. Like you can play around with it, change some stuff around. I'm going to finish. And maybe what I'll do is I won't print the line. I'll print you said. So you can change the code around and then run it, which is kind of nice, right? You said Mike. You said Fudge. Finished. And there you go. So this is what I like about the Severance book and the trinkets is you get to learn about concepts like things like continue and break and see how they're applied. One other thing to note about the content is when Monday's lecture is finished, it will be posted here. This is a placeholder for it, but after Monday's lecture, the video from it will get posted here. There's also content that lets you see the lab walkthroughs and the homework advice. So every week there's a lab and there's homework. The lab walkthrough is a way to sort of help you if you're stuck in the lab. That's the course content in a nutshell. Searchable, connected to the syllabus, video, text. The textbook from Severance is free, and it's all available on this website here, IST256.com. All right, next let's talk about Jupyterhub. So Jupyterhub is a programming environment so that you don't have to figure out how to install Python on your computer. So it's full-blown Python plus a virtual machine that runs Linux, accessible in a browser, uses notebooks, which computational notebooks are very popular in the data science / information science world. And it's a very easy and convenient way for you to code, and also a very easy and convenient way for me to share code with you. In Blackboard, you'll see a link for Jupyterhub. Click on that link and it takes you out to hub.ischool.seer.edu. You just log in with your net ID. And this is the image page. You're always going to want to pick the IST256 image. You have to do that every time. It's not a big deal. And what it's doing right now is it's setting up your virtual machine and connecting it to the website so that you can see it within the browser. And when it's finally loaded, it doesn't take long. As you see, you'll see these folders, datasets and library. The code is in the library folder. Down in here, you won't see all these folders. You're just going to see an IST256 folder in your setup. And then in there, you won't see all these folders either. You're just going to see one for the current semester, like spring 2023. From there, you should see, whoops, I'm going the wrong way. You should see a list that says lessons. And under lessons, you'll see a folder for each lesson. And these folders match the lessons on the website. So if you go to content, you'll see, oh, here's lesson 3 conditionals. See that? Lesson 3 conditionals. And I go back to Jupyterhub, lesson 3 conditionals, same folder. And in every folder, there's the same files. There is a set of slides. These are the slides that we use in large group. There is a file called large group where you can open this up and type your notes in it, or some of the code that I do in large group you might want to put in there. There is a folder, there's a file here for the lab and for the homework. So when you want to do the homework, you open this one up. When you want to do the lab, you open this one up. When you're in your recitation, you'll open up the small group one. These other ones, these WMCs, these are preloaded examples based on what I've done in the lectures in the past. Sometimes in the lecture, I'll do something different. There is a video that you can watch. I strongly encourage everyone to watch it in the very first week in introduction, called Quick Introduction to Jupyter Notebook, right? And that will explain to you how to use this notebook environment. Like if I type in code here and run it, I type in code, how do I run it? There's a button here that says run. You'll see I can also run it without pushing that button. So it's like, how do I do that? There's shortcuts. I can turn line numbers on and off. Those are all shortcuts that you'll see in that video. So basically that's Jupyterhub. It will stay logged in for as long as you're doing work. If you close out the browser like that, what will happen is eventually it will log you back out again. You'll see that some of these notebooks are green. That means they're running, they're consuming disk space and memory in the virtual machine. If you go to the running tab up here, you can see which ones are running and you can manually turn them off. When you're done, you can always log out. If you ever need to stop your virtual machine and start it again, sometimes you need to do that. I'll tell you, restart your virtual machine. You go up here to this control panel and you hit stop my server to do that. That's basically Jupyterhub. All right, let's have a little discussion about what kind of stuff happens in the large group or the main section on Mondays. The major emphasis of what we do in the large group on Mondays is reinforce the readings from that chapter. So if you're on the website and you're in chapter 3 and you read through this Severance and maybe watch some of these videos here, you might have some questions about how things work, like try except, or what the difference is between if or elif. Those things we clarify in the large group. In large group, there's always a notebook called Slide. You'll see when you come into class on Mondays, I will have the slides up. They're in Jupyter, and I just click this button here, and you'll see I have a slide page like this that shows up at the beginning of every large group. It always has an overview. I'll give you an example of a more realistic one and what it looks like. Let me go into a different unit here. It always has a place where you can sign up for the polling and a place where you can sign up for the chat. These are two things that we use in every large group so that you can participate. Again, it's a big lecture hall. It's intimidating. Sometimes you might not want to raise your hand. You're encouraged to raise your hand if you want. Sometimes you might not want to. So what I do is I offer you other ways that you can interact with me in the large group. Throughout the large group, I might be doing some coding. The notebook file is called large group MA Fudge. See that? And you see this notebook file usually Tuesday after large group is over. I save it, and then when you log back into the Jupyterhub, you see it. And so every code, all the code I write in large group, you will have access to. It's there's no need to sort of keep up with me as I write examples in large group. There's also another file in large group just called large group, and it's usually empty. There's nothing in it. But here's where you can write code or try things out, or maybe you see me do something and you want to try it out, so you type it in here. Maybe you want to jot down some notes. You can always go to the markdown cell and see, and you can just write some notes in here, just a simple way, just giving you options. You don't have to use it, but it's there for you if you want to. You see that I'm a big proponent of like letting you decide how you want to consume the materials I've given you, and I give you a lot of options. You want to ask questions. That happens a lot. So there's a couple ways you can get to our Teams channel where you should be asking questions in large group and outside of large group that you want someone to you want someone to be able to help you with the answer. So if you go to Blackboard, you'll see it says help office hours here. And then in here, you will see it says ask question anonymously. No one will know who asked this question. So you might say, are you a smart prof? A lot of students will use this in their large groups to ask me a question, and they don't want me to know who they are because they're sort of intimidated by the question that they're asking. I encourage you to not use this. It's there to, it's there for some of you, but get comfortable asking questions as you. Trust me, if you think that your question is trivial, I'm going to tell you right now from my experience, if you're asking it, there's 20 other students that have the same question, and they're all afraid to ask it. You need to get over the fear of asking questions. So, okay, you ask the question, where is it? It's going to be, if you click on Microsoft Teams, this will take you to our Teams channel, and hopefully it comes up. See, it says questions. See that? Questions. And if I go to the questions box, you can see the questions that have been asked. If you're logged in as you can always ask a question here. Where is the homework file? So when you ask this way, the way I just did it, you will see your icon here as it's logged in as you. And you'll see that. If you want to ask it anonymously, you should use this form here. Okay, so that's how you ask a question. What is happening here is when we're in large group and we're going through these slides, right? We might be knee deep in these slides somewhere. Someone will ask a question on Microsoft Teams. I will have Microsoft Teams open when large group is going on. And if I see a question pop up, I will field the question right then and there. I also have all of your recitation instructors are there. And sometimes if they see a question that you ask, they will raise their hand and get my attention to let me know that you have asked a question. It works very well, and I encourage you to use this system to ask us questions. One other thing that happens in large group is, I ask you questions. So you ask me questions, and then I ask you questions. This is all part of the active learning. The science behind active learning is that rather than just an information dump, we want to make it interactive. So we have these areas where we will ask questions. So this is an example of a slide that you might see in large group where I am posing a question to the 100 some odd students who are in the large group. And it will always have this vote now, and then there's a link, pollist256.com. This is a website that you go to pose your question. And you can use your phone. You can use your laptop. It doesn't matter. You just go to pollist256.com, and you're not an admin, so yours would look like this. And it'll say, vote now, your name, so it knows who you are. And I use this for attendance purposes and also to figure out who's actually participating in the class and who's, not there just shopping or watching ESPN. And then you'll see these, this multiple choice, A, B, C, or D, and then your vote is, which one do you think is right? So it says these statements are out of sequence. Which letter represents the third step in this program? I think the third step is C. Okay. Then it tells you that you voted, tells you when you voted, makes a little funny comment about you voting. And what happens is this vote is recorded, and then I can present to you a graph that shows the responses to the poll. And here's the one response to the slide. And usually we'll have the responses lined up like this, right next to the slides like that. And people are answering the poll in real time in class, and this graph is changing in real time as people answer. And there's a little bit of a network effect going on where people always want to pick the most popular answer, even though that's not the right answer. Polls don't really count. I don't grade the polls. That's not the point of the polls. The polls are just there to measure your participation in the class. And we do look at it, and we do take it into account, and we use it to get a whole profile of you as the learner. So it's important that you participate in these polls, even though they're not graded. Not everything needs to be graded to count for something. We will reach out and mark you for poor attendance if you are not participating in the polls. For every topic in the course, there is a coding lab. Let me show you what the coding lab entails, how to find it, and more importantly, how to hand it in. In any given lesson that we have in the Jupyter notebook, I will see a notebook file with the word lab in front of it. That represents the lab. All the labs consist of some reading and some doing. So you'll see that there's, let's read what's happening here in the lab. And then when I want to do this, I should run this code. Okay, and so I will run the cell, see what the code does. Okay. And this is part of the early learning process. So you'll go through these cells and you'll read the context. This is important. And then you want to make sure you run all these cells as you do them, because if you don't run this cell and then you run this one, it gives you an error because you didn't run the cell in front of it. So you learn a lot about how notebooks work by following the lab instructions, especially early on, and doing what the labs ask. Eventually in the lab, you will come across a part that says you code. And when you reach this point in the lab, it's time to make an attempt to write your own code. So it says rewrite the program above and input a name and then say hello there name. It will need to store the first line in a variable that can be printed on the second line. You're going to try to rewrite this code to do that. And so this is really on your own. And so some of you might have a hard time figuring out how to do this. You might have a hard time connecting the dots from the things you've done up here to finally getting down to here where you actually got to write some code. If you're stuck and having some difficulty, and only if you're stuck, I encourage you to try it. Maybe you don't get it right, and that's fine, but try it, right? But if you're still stuck, again, if you go out to our content, there is a lab walkthrough. And for any given lab walkthrough, let me click on it. So here's my lab walkthrough, and you can see I can skip around. I'm having trouble with ucode 1.1. See that? So I can skip to ucode 1.1 and just watch. You can watch me program U 1.1. If you're having trouble with 1.2, you can skip. So now I'm looking at 1.2. So I can skip around and look at the bits and pieces. Let me go down here further in the lab. Here's 1.4. So I'm having trouble with 1.4, having trouble with writing the code right here. I can skip in the video and watch it. And that's helpful because, again, you're early in the learning process in the lab. We don't want you to get frustrated. You probably shouldn't just go and watch the video and then just do the lab. That's not really kind of the point. It's not, it's supposed to be a learning exercise. So again, in order to learn, you have to struggle, right? When you take up piano or violin, right? You're not very good when you start, or the drums, right? And then the more you practice, the better you get because you learn from your mistakes. And that's what we're trying to do here is mimic that aspect of it. So when you're done with the lab, there's a portion down here called Metacognition, and this is really important to the lab. So when you're done, you should click on this cell here and then give yourself a grade of 1, 2, 3, or 4. This is how well you are understanding the material so far. 1 is, I'm not understanding it very well at all. 4 is I'm understanding it so well I probably can explain it to my mom, for example. And all you need to do is click in this area here and then at the bottom, put in a number. 1, 2, 3, 4. And then you want to run the cell. Okay, that's step 1. Step 2 down here, you want to record any questions or comments or thoughts about the lab. So this is where you give it a chance to reflect and maybe ask a couple of questions. So you might come down here and say, I still don't understand when to use a variable and why they are needed. I selected a 4 because I can explain everything else. Use my bad typing. You get the point. This is important. We look at this. Your recitation instructor reviews these before class and uses this information here in conjunction with this information here to plan for small group. So if you don't do this, we can't get a full credit on this lab. So it's important that you give yourself a rating, be honest. It's not like we're gonna flunk you if you put a 1 down. And then down here, try your best to ask your questions that you have and explain where you are as a learner. And again, when you start out, this is gonna be very challenging to do, but as you do it, you're gonna get better at it. How do you hand this in? You don't have to turn this into Blackboard or anything like that. We have a full submission system that we built in the notebook. So all you need to do is you run this code here, and it will bring up this, which is a header that explains what you're about to turn in. It reads it right off the syllabus. So if you go back to the website, I go down to the syllabus, and at the bottom of the syllabus, there's a what's due. And it tells you everything that's due. See that? I practice what I preach. This code here reads the syllabus, and it figures out from reading the syllabus that it's worth 3 points and it's due on this date. It's worth 3 points and it's due on this date. See that? Perfect, right? And then when you want to hand it in, you just hit the submit button. And whenever you submit it, you will get this, and that tells you, this receipt tells you that it was handed in safely, and we'll be able to get it. And what we do later on is we retrieve it. And so there's reports that we have that will let us retrieve your lab, compile all the questions, and then prepare for the recitation with your questions. In this section, we're going to talk about your recitations. So recitations are on Wednesdays, and in the recitations class with about 20 to 25 of the same people every semester. They will form what's called your small group, and in your small group, you will do your recitation. In Jupyter, you will find a small group notebook that your recitation instructor will use. And in the small group notebook, there is some activities, and you will generally do these activities together, and you can put your code in here. Now, how you will go about putting the code in there depends on your recitation instructor. Your instructor may ask you to try it on your own. He or she may have you pair up with somebody else in the class and figure it out together, and then both of you put the code in there when you're done. They may have you work on it as a large group all together verbally, and then work through it that way. Any materials that your professor needs to share with you, you can find those on Blackboard. So if you go to Blackboard, there is a content folder, and in the content folder, you'll see that it has recitation folders for each of the instructors and the days and times that they teach it. So if you were in Recitation 6, you with Professor Reeks on Wednesdays from 3:35 to 5:05, this folder here, which is going to be empty because the class is just starting, would contain all the materials. So in here, Professor Reeks might have a link to a Google Doc where she can take attendance in the recitation and then maybe also share some code with you, and you could copy and paste it out of the Google Doc. This is where the recitation instructors have a lot of latitude in how they go about doing things. Ultimately, we're all going to have you turn in this assignment, this small group assignment here. How we go about doing that is really up to your instructor, your recitation instructor. At the bottom of the recitation is a course submission document, and you usually have to hand this in for credit. So unless you turn this in, you will not get credit for small group. Some of your instructors also look at other factors of the recitation because there's 3 points here. You're not going to get all 3 points just by filling this out. Sometimes you might have to participate, and they keep track of that somehow, usually on a piece of paper or with a spreadsheet. Sometimes you might have to contribute some code in a Google Doc and then put your name on it so they know you've contributed. And they use that to keep track of who is participating and engaging in the small group. And then that goes into the grade that you get. And if you hit the submission script, you'll see that you get 3 points for small group. Again, it's reading the syllabus. So if I go over to the syllabus and look at this small group, SO1, 3 points. This is when it's due. It's due in class. When your class ends at 5 o'clock, we expect you to turn it in. This is not something you should be doing on your own. You should be doing it in class with your instructor. The 3 points is only guaranteed if you participated in that small group, if you were engaged in the small group, if you were present in the small group. That's the only way that you can guarantee you're going to see all 3 of those points. By far, the most challenging thing you will do in this course, besides the project, is the homework. For any given lesson here, I'll go back to the first lesson again, there is a template here called HW, and that represents the homework. And if you go in here, there is a instructions on what we're looking for from your homework. There's a place where you write up a problem analysis, and then usually space where you can code up a solution to the homework. And then after you've coded up the solution, usually we'll add a couple of questions that we ask you. These are usually just to get you thinking about what it is that you did. And then there's a space where you can reflect. You should share your thoughts just like you did in the lab. Keep it to about 100 to 250 words. What did you learn? What would you do differently? Where did you struggle? How did you overcome it? Who helped you? How did they help you? Etc. Homework is challenging because it is the only formative assessment that we expect you to try really hard to get correct. We also do not want you working with other people on your homework, and you should disclose if something or someone helped you with the homework. It's an academic integrity violation to complete the homework and not disclose the sources of the entities that helped you. Those entities could be an AI bot, a tutor, a classmate. We certainly don't want you working together, but you might ask a classmate how they approached part of the problem, and then if you do that, you should make sure you credit that classmate in your reflection. That way, it's clear to us how you went about solving the problem in the homework. If you are just copying the homework, you're going to get in trouble, and it's going to be an academic integrity violation, and we report those all the time in this class, unfortunately. So let's talk about completing this homework then. If you're having trouble getting started on the homework, that is, if you're having trouble understanding the problem, then the place to go is in the content section. There is a homework advice video. This homework advice video will sort of walk you through algorithmically how to solve the problem. There's some code that is written here, but it's certainly not going to complete the solution for you. That's not the point of the homework advice. It is just advice. And you don't even have to follow the approach of the advice. You can come up with your own approach. That's highly encouraged. It's really just for people that are stuck, or they really are having a hard time comprehending what the actual problem is we're trying to solve in the first place. You should always do a problem analysis. In the problem analysis, what we're looking for is you to write up what the inputs are, what the outputs are, and then at a very high level, how you go from input to output to solve this problem. So for example, you might say, well, the inputs are, I'm going to enter a name and an age. Take out that to do. And then my outputs, I'm going to enter that it's going to output the name and then the age, and then or years to retirement, assuming 65 years is retirement. And then you'll write the algorithm here, and the algorithm should look something like, step 1, I need to input the age. I need to ask them for their age. Step 2 is I need to input their name. Step 3 is I need to calculate days to retirement, mainly 65 minus the age. And then I'm going to output the name, age, and days. Or it should be years to retirement. The point is, this does not have to be, one line in the algorithm for one line of code. We're not really looking for that here. What we're looking for you to do is just think through the problem. I don't want to see you write code and then turn your code into an algorithm. That's pointless and useless. Just think about what you're going to do before you do it. And then down here, you're going to end up writing your solution. You might have like age is int, input, enter. You write your solution down here. And then again, you'll fill out the questions and then reflections. And then when you're done, you'll turn it in with the submission script. All right, let's talk about if you need help with your homework. How do you go about using the AI programming assistant that I provided for you to help you with that? Okay, there's a couple things. There's a lot of, the landscape's changing a lot. There's, a lot of different ways that this can be done, whether it's GitHub Copilot or Chat GPT. What I'm doing as part of my research is I'm providing a bot to you that is the equivalent of those, and it's built right into Jupyterhub. And you can use it, and you don't have to pay for it, right? You don't have to make a decision to pay for one of these assistants. And in exchange for using the assistant, I get to study just how this affects learning in a programming course, because I recognize that these assistants are the future of programming, and so I'm trying to embrace that. So let me show you first how you invoke using the PyBot, and then secondly, after you invoke it, how do you make sure you're using the PyBot properly in your homework assignment so that you're not creating an academic integrity issue. Let's invoke the PyBot. I'm going to add a cell here. You need an empty cell. And in the cell, you say %PyBot. And if I want to get some help on PyBot, I can just do PyBot question mark. Oh, I got to give a couple of extra lines in there. And you'll get some help. So I can do PyBot. PyBot debug will debug code for me. PyBot op changes whether or not I want to participate in research. Before you can use PyBot the first time, you have to decide whether or not you're going to allow the data it collects to be used for research. I highly encourage you to do that. I'm going to anonymize everyone anyway, so it's not a big deal, but I do have to ask you if you would like to participate in research. So let me give you an example of using PyBot. So I'm going to take and ask PyBot a question. I'm going to say PyBot, and then I would say, write a program to input and age and output the person's age. All right, let's see if I have it working now. So run my PyBot, and I get this generated output. And then I can run this code just to see if it works. Enter your age, I don't know, 45. Your age is 45. I can add 10 to that, 45, and see, it's a number, so it's 55. That's great. So here's what I'm talking about. If you use the PyBot to help you with your homework, that's fine. What you need to do is you need to leave the cell where you asked the PyBot to write the code, the code that you used. You need to use that. You might write this prompt several times before you find the right thing, but when you find the right thing, you want to leave this in your homework. Then you want to leave the output in your homework. And then the code that you use, you can copy that and put it up here, for example, like that. Okay, but you want to leave these here. Now, if you need to use the PyBot again, you should add another cell and do that. Leave every time you use the PyBot and it generates a solution and you use a solution, we would like that to be added to your homework so that we know where the code came from. It's fine to use the assistant. Now, if you use the PyBot and it doesn't help you, like if I say PyBot and then I say add calculate retirement age in Python, and it doesn't help me, like this isn't helpful. I don't even know what this is at this point in it. So I don't need to keep these cells here because they didn't help me. So I can just remove them. Only leave the ones in there that actually contribute to your solution. I'd like to conclude with a very quick discussion about due dates and feedback. The grades that you get from us, you will be able to see in Blackboard. If you go to the My Grades tool here in Blackboard, you will be able to see right now every single assignment and its due date are posted in Blackboard. And when you get a grade, there will be a number here. And when you click on the grade, you will see our feedback. And we try to take the time, especially in the homeworks, to give you some really good feedback. In the labs, we're giving you feedback in small group / recitation. And in the small group, we're not giving you feedback because you're already there in class. There might be a comment as to why you got a 2 or a 1, and you'll be able to read that feedback in there. But as far as actual formative feedback, you're going to be getting most of that in your homework. You're going to be getting the lab formative feedback in the recitations. That's where you can go to get your feedback. You'll always be able to see which is your point total, and then you'll be able to match that point total to the syllabus to figure out sort of where you're standing in the class is. If you go down to methods of evaluation, and then there's a grading scale, this will tell you how many points you need to achieve the grade that you're after. The last thing that I'll mention, again, one more time, is all of the due dates. So the due dates are in Blackboard as well, and they are also right here on the syllabus. You'll see that there is a what's due. You can use that to sort of track where everything is that's due, including the exam date. Well, that's it for the survival guide. I hope you found this very helpful and useful, and look forward to seeing you this semester.